And let's say problem 26. Okay, so x plus 1 divided by 4 equals 1/6 plus 2 minus x over 3. What type of equation is this? That will always be my first question. Why is this always my first question? Is because I'm assuming and hoping that if I identify it correctly, I will be able to solve it correctly. So I will always ask you what type of equation we are given, and then we will figure out how to solve it. So what type of equation is it? This is tempting because I see a fraction. But as long as it doesn't have x in the denominator, it's still linear. So a rational equation is a very good point. A rational equation, you can write it down, and I will write it down with you if you want. Note, a rational equation must have a variable in the denominator. If it doesn't have a variable in the denominator, it's not rational. So this is still linear because the variable has power 1. Next step. What do you think we should do first? I see a linear equation, I see 3 fractions, and I ask myself, what should I do? I may have said this, and I'm going to repeat myself a lot. If I didn't, I'm going to write it right now. 2 key words that have to be kept in the back of your mind at all times. One of them, factor, and simplify. Thank you very much. So every equation I'm given or any problem I'm given, I'm going to try to simplify it, especially an equation like this one. So how can I simplify this equation and make it more human? The least common denominator and multiply everything by it. So what is the least common denominator of 4, 6, and 3?
12.
Awesome. 12 is the least common denominator. I am going to multiply each and every term, everything, by 12. So here's how I do it. I'm going to copy the equation. So I have x plus 1 over 4 equals 1 over 6 plus 2 minus x divided by 3. You gave me the correct least common denominator. Since they're all fractions, I'm going to write 12 over 1 times 12 over 1 times 12 over 1. Always remember the key words, simplify and factor. Do not multiply and then simplify. Always simplify and then multiply. So when I simplify 4 and 12, what do I get? Right, so I get 3 parentheses x plus 1. Excellent. When I simplify 6 and 12, what do I get? 2. Very good. Plus. When I simplify 3 and 12, what do I get?
4.
Very good. I hope you agree that this is way more human looking, right, than the previous equation. We have not changed the solutions. We just simplified the equation by removing fractions.
Sorry,
Yes,
just
go ahead. Any question, anytime.
I mean, one time, what we do, so the 4 goes into 12, and then it's times 1.
I simplified 4 by 4 and 12 by 4.
Okay.
I simplified 6 by 6 and 12 by 6. And I simplified 3 by 3 and 12 by 3.
So 4 goes into 12, is 3, and then 1. You know, like the steps, because it's the basic thing. So it's 4 divides into 12, and you get 3. And then the x and 1 is in parentheses because it can't go in the 12. Because it's already simplified.
No, I'm writing the next step so everyone sees that I have to distribute 3 to x plus 1. I cannot just write 3x. it has to be distributed to both terms.
Okay.
That's why I have to write parentheses at this stage.
Okay.
For everyone to see that eventually 3 will be distributed to x plus 1, like 4 will be distributed to 2 minus x.
Got it. So you're just doing the denominator.
I'm only,
8 to 12.
I'm only eliminating the denominator in this stage.
Okay.
Correct, yes.
Okay. So you're just copying whatever's on top. You're just putting it, right?
I'm distributing 3 to x plus 1 right now. Yes, because I'm simplifying.
Okay.
Is that okay?
Yeah. So what's in the parentheses stays the same, it doesn't change. Or like the x plus 1 and 2 minus x, it doesn't change. You just put it in parentheses to distribute it.
Because I have to distribute 3. I'm only simplifying 4 and 12. I cannot simplify this. I can only simplify what I can simplify. So I have 12 multiplied by this divided by 1 times 4. And I can only simplify this. And this stays. It's x plus 1. I can't do anything to it.
So what if it was a number at the top that you could simplify?
But I don't need it. I already got rid of the denominator. I don't need, even if I have 3 times 16 divided, 12. I can have 12 times 16 divided by 4. I still want to do this. I can do more. This doesn't mean anything. If it's a number or not, I can simplify it by 4, but I already simplified by 4. I simplified 12 by 4, and I simplified 4 by 4. There is no point in simplifying with this, because this is gone. 4 divided by 4 is 1, 12 divided by 4 is 3. So now the answer is 3 times 16, like here, 3 times what I had at the top. Once I got rid of it, of the denominator, it's gone. Better? Okay, so then we have now 3x plus 3 equals 2 plus 8 minus 4x. Make a star next to the problem if you still want to go over it again. At the end of the class, we can do it again. Just put a little star and stay after class so we can do it again to make sure that this is clear. So then 3x plus 3 equals 10 minus 4x, because as we know from last time, we have to simplify both sides. And now I move x and I move 3. So when I move 4x to the other side, I get 7x. When I move 3 to the other side, I get 7. Remember, when we move a term from one side to the other, it changes its sign. And finally, we get that x equals 1. Any questions on this? Any questions? Is this better? Okay, moving on to rational equations.
Can we do one more of these?
Yes, of course. Yes, of course. So here it is. Let's say 29. That is x plus 1 divided by 3 equals 5 minus x plus 2 divided by 7. X plus 1 over 3 equals 5. X plus 2 divided by 7.
Equals 5, what? Is that minus?
Yeah, by mistake I wrote plus, but it's minus.
Okay. So it's gonna be.
I just erased it. Okay, so the same idea. What type of equation is it? It is linear because it doesn't have x in the denominator, although it has fractions. Awesome. And now I would like to eliminate fractions, multiplying both sides by the least common denominator. Excellent. Multiply by 21. So I will multiply by 21 over 1. I will multiply the integer by simply 21. I don't need to put it over 1. And I will multiply the fraction by 1. So then 12 over 1. So I see that I have to simplify.
Okay.
So now when I simplify by 3, what do I get in front of x plus 1?
7.
Good. So I have 7 times x plus 1. When I multiply 5 by 21, 105. And when I simplify 7 and 21, I get
3.
yes. So then I have minus 3 times x plus 2. Now, do we understand this step?
Yeah. Okay, I understand. You're
it
just going
too
fast. Yeah, I get it.
These are linear equations.
I understand it, but how I do it to remind myself so I can remember the steps while I'm practicing, I do my 21 over here. Like I go to the next step, but I show myself, and how you can do it because you have red pens is different. Like I have to show myself as I'm writing.
Good.
So you move, I might have to drive the class because this is too fast for me.
So what would be the next step?
Like I get it, but it's just too fast. It's not even.
Good. That's what I said. Just make a note and let's discuss this again on one-on-one. Very good. 7x plus 7 equals 105 minus?
3x plus 6.
Careful.
3x minus 6.
Awesome. So now we simplify both sides as much as possible. And the right-hand side is negative 3x and plus?
Equals 105 minus 7
Minus 6 is 99. And then minus 3x.
4.
Are we okay so far? Everyone? So at this stage, we move x to one side. I recommend the left-hand side, but the right-hand side is fine too. It's not a problem. Stop me if you have questions. Anything? So 7x, and I'm bringing a 3x. What do we get on the left?
4.
10x.
10.
When we move, yes, because when we move a negative term to the other side, we get positive. And then we subtract 7 from both sides, and we get 92. So x equals 92 divided by 10. And you don't have to do anything else. Any questions? I would definitely simplify top and bottom by 2, but I will still keep it as a fraction. So 1.2 equations we started last time. Yep. Yes. Please remember to redo the problems we do in class as many times as you need till you are able to perform them or solve them on your own without looking anywhere. That's the very first step. That's the basic step. Okay. Any questions on this? Are we okay? Everyone, are we okay? Okay, the next step is rational. Rational equations are among, in my opinion, among the most sophisticated equations. I would not ever consider this a trivial equation. So let's start with one. We are still on page 120. Let's look at problem 47. Still on page 120. So this is 2 over x plus 1 minus 1 over x minus 1 equals 2x divided by x squared minus 1. Not a trivial situation at all. This equation, so in your notebook by now, we should have, if you're using one, we should have all the 3 special products from last time. We should have the steps of solving a linear equation, what we have to do step by step. We should have that in our special notebook. And now this is a third topic, which is way more sophisticated and more difficult than the previous 2. Okay, a rational equation. As I mentioned before, if I didn't, forgive me, I'm mentioning now. I will show a method that I think is the easiest to understand. But it may not be the easiest for some of you. You may say, I know a different method, and I will stick with mine, and I'm happy for that. If you know a method and you're comfortable with it, do not change to mine. Okay? Now, if you think, after we finish the first problem, or maybe even the second one, if you think that my method is easier, then you can adopt it. If you don't think it's easier, forget it and use your own. Okay? Good enough? Fair? Okay. So a rational equation is totally different than a linear equation. What I would recommend is move this term to the other side, and if I do that, what is left on the right-hand side? Of course, if I move the only term or the only expression that is on the right-hand side to the left-hand side, obviously there is nothing else left. So then I have 2 over x plus 1 minus 1 over x minus 1. And what do I have to write next? Of course, 2x at the top. And now I have to stop for a moment and think. Because I reviewed this special product on Monday. So let's think. Which special product is this and how do I factor it? So in my notebook, for important steps, I would write, in order to solve a rational equation, I moved the terms from the right to the left, and I was left with 0 on the right. Secondly, I make sure that all factors in the denominator, or all expressions in the denominator are factored. That's my next step. So from last time, we know how to factor x squared minus 1. How do I factor it?
Let's write it twice.
What do you mean by twice?
So under it would be like in parentheses, I'm trying to remember, x plus 1 and x minus 1.
Awesome. That's all I needed. Excellent. Indeed, this is a difference of squares. X plus 1 times x minus 1 is x squared minus 1. Excellent.
Yeah, this would be good.
You are very good. It's coming back. Excellent. Well done. Okay, now we have to write the restrictions on the variable. What is that? We have not done this with linear equations. Why? There were no restrictions. The variable is fine, but here the variable is not fine. And when is the variable not fine in this problem? What can go wrong here?
Get something other than 0
Where?
in the
Exactly. In the denominator. So note, division by 0 is
1.
exactly undefined. That's why we can't have it. It cannot be 0. It cannot be 1. There is no number. It's undefined. This is a fancy word for saying it does not exist. Since the denominator cannot be 0, x plus 1 cannot be 0, which means if x plus 1 is not 0, this is a linear equation, it means that x cannot be
0, 1. 1.
I have to move 1 to the other side. That's how we solve a linear equation, correct? And when I move 1 to the other side, what happens? Correct. And then from x minus 1 cannot be 0, which means x cannot be?
plus 1.
Exactly. So if I solve the equation and the solution or solutions are plus or minus 1, what will I say about this equation? It has no solutions, because I cannot accept a solution that is already a restriction. It can be.
You said it is not what? If it is not what?
If I get the answer to be 1 or negative 1, I will say no solutions because these are the restrictions. Very good. Now let's find the least common denominator. Can anyone give us the least common denominator?
X plus 1.
Very good indeed. X plus 1, x minus 1. All different factors have to be in the least common denominator. Excellent. Well done. Okay, so now here's my next step. I'm asking myself, if x plus 1 was multiplied by to get this, what was it multiplied by to get this?
1.
What do we multiply x plus 1 by to get this? Very good. Which means that we have to multiply the numerator by the same quantity. We multiplied x minus 1 by,
X minus, X plus 1.
very good, awesome. So we have to multiply the numerator by the same quantity. And we multiply the denominator of the third fraction by what to get this? By what? X plus 1 times x minus 1 times what is x plus 1 times x minus 1? By? Say it again.
1?
Exactly 1. Or you don't have to write anything. So now please tell me or dictate the numerator of this fraction. Let's do that.
The numerator is.
Obviously, you have to distribute 2 to these two terms. 2x minus 2. Very good. Now you have to distribute -1 to these two terms.
Yes. It's
Negative x.
-1.
Very good. And now -1 times 2x times 1. Sign. Sign, but I cannot write 2x. I have to have a...
Sorry, plus. No,
Minus.
Minus, it's minus.
These are
Okay.
also know how you find
Very
it.
good.
Okay, so what's that bar? That one.
Say it again.
The line in the equal 0, so that's just something, a reminder.
This is the least common denominator. We are adding 3 fractions and we still have a fraction left.
Okay.
Very good. So let's combine like terms at the top. These two go away. We have -x. How much is
what?
I did this different.
we have -x. -2 minus 1 is
-2.
very good. Divided by x plus 1 times x minus 1. Now, I have a question for you. Would you agree that if I can write 10 as 10 over 1?
No.
Yeah, it's the same thing.
Can I write -3 as -3 over 1?
Yeah.
Can I write x as x over 1? Then you will agree that 0 can be written as 0 over 1.
No.
I just repeated the same thing for all numbers. 0 is also 0 over 1. So the right-hand side, it doesn't matter. It doesn't matter. It's the same thing. 0 or 0 over 1 is still 0.
I did 0.
The reason I have $0 and I want to share it with one person. How much will you get? 0.
So x, negative x minus 3 equals 0.
Correct. I'm going to get to that. Exactly. So this is a very important type of rational equation called proportion.
I always thought x was 1.
So what are we allowed to perform in a proportion, and only in a proportion? This exactly. So this is just a very important topic. Only in proportions we can cross multiply. I hope you understand that we could have not cross multiplied from here, because this is not a proportion. What does a proportion mean? It means one fraction on the left-hand side of the equal symbol in the middle, and one fraction on the right-hand side of the equal symbol. This is a proportion. And a proportion allows us to write A times D equals B times C. Very good. So now coming back to our problem, what will you say? How much is -x minus 3 times 1? It's -x minus 3 equals, so this product is -x minus 3 equals this product. How much is this product? Very good. So therefore, -x equals 3, or x equals -3. We have to multiply both sides by -1, or divide both sides by -1. My first thought is to go and check among the restrictions. Is -3 in the restrictions list?
No.
No. So this must be the correct solution. Let's work on another. I don't expect everyone to understand everything fully from the very first problem. It just needs, you need to see this several times and you need to redo it at home several times.
So that answers x is -3.
Correct.
Okay.
Correct. Let's choose another problem and see how this works again. Let's say 48.
I have one question about
Please
that.
do.
Could we since it was 0/1, is it basically like you said, you multiply it and then you end up, but x can be negative, so you just split
X
it.
can be negative. X cannot be plus or minus 1. But X can be anything else.
I mean, but I'm sorry, I said that wrong.
That's okay.
So at the x negative x minus 3 over x plus 1 and minus 1, right? And it's 0 and 1. To get that answer to that x equals negative 3, you could just move it after you multipy it, cross multiply on
Yes.
the other side.
Yes.
That's what you did.
Well, yes,
Okay.
because this becomes linear now.
Right, okay.
So we
got
move.
you.
Now,
Alright,
also,
okay, I got it.
there is another way from here.
Okay.
I just wanted to refresh your memory on the proportion and why proportions are so important. But from here, you can also say, when is a fraction 0? When a over b is 0? Only when. When is a fraction 0? Only when. Excellent. Only when the numerator is 0. So from here you can say, forget about your proportion, I just needed to review that with you. You can already say negative x minus 3 must be 0. Because a fraction is 0 only when the numerator is 0. And this is exactly what we got anyway, by cross multiplying. But you can shortcut this and say, oh, I got to have negative x minus 3 over something equals 0. A fraction is 0 only when the top is 0, and you're done. If that's easier for you. But proportions are very important, and I needed to review the cross multiplication rule. Very good. So can anyone give us the steps? Yes, this is a long procedure. It's a long problem. It goes through many steps. So can anyone refresh our memory? What will be the first step?
You have to move.
Yeah.
Yes, if you use my method, please do. So 4 divided by x plus 5 plus 2 over x minus 5, and then you write
Minus 32.
over, and the denominator will be
X plus 5.
excellent, equals, and what is left? Exactly. Remember, each equation has a left-hand side, one left-hand side, one equal symbol, and one right-hand side. You cannot simplify to the sides. Please do not do that. They will be wrong. Good. So now you're going to give me 2 restrictions because we have 2 different factors here. And the restrictions are excellent. Very good. Plus or minus 5. Then you will give me the least common denominator. See, once you see with first example, with patience, when you get to the second one, it's going to be much easier. What will be the least common denominator now? Very good. Awesome. Then we have adjustments. The top fraction gets, very good. The top of the first fraction gets x minus 5. The top of the second fraction, very good. And the last one, very good. So now please dictate the numerator.
Okay, so why do that one get 1?
Because it has the same denominator. There is nothing,
Oh,
there is
okay,
no
okay,
additional
okay.
factor. Or you don't have to write anything. If you
Okay,
don't write
so
anything, it's fine too.
Okay.
So can anyone dictate the numerator?
4x minus 20.
Very good. Very good. Now, let me say one thing. I accept other methods, of course, but let me just show you why,
I
because
did it a long way.
because this is very important what I'm going to show now. Here's why I don't write the intermediate step. There is an intermediate step. You can write it if you want, but I'm going to show you why I don't. Okay? But it's up to you. You decide. I do not write this. It's not wrong. Here's why I refuse to write this. Because some of you will be tempted or may be tempted to do this.
Yeah, that's what I.
And that will be a terrible mistake because you can only simplify, and let's write that big note. That's another super important piece of information. Never simplify terms, comma. Simplify, or colon, simplify only, what keyword I'm looking for? Yes, yes. What? Only? Danny?
Factors.
Excellent. So that's the reason why you cannot take a piece from a term and simplify it with a factor. You cannot take a piece of a term and simplify it with a factor. That's the reason why I refuse to write this step. But if you know what you're doing and you will never simplify, you can write this intermediate step. I instead prefer to multiply these two and put them here, multiply these and put them here, and multiply this and put them here. And now I'm hoping that no one will try to simplify anything, because you can't. There is nothing that is like. But here, you may be tempted to take these two away, you may be tempted to take these two away. Also, if you write this without the denominator, I'm fine too, because it's correct. But if you write it with a denominator and you start simplifying that, it will be a collapse, total collapse. Okay, so now let's simplify the numerator. And what do we get in the numerator when we do that? So 4x plus 2x is very good, 6x indeed. And negative 20 plus 10 is negative 10, negative 42. Divided by x plus 5, x minus 5 equals 0 over 1, which will refresh my memory saying, oh, 0 over 1, so it's a proportion, now I can cross multiply. Or you can say it's a fraction that is 0. The numerator must be 0. It's up to you. Or cross multiply and you get 6x minus 42 equals 0. Therefore, x in this equation is
0. You gotta add 42 to 5.
very good.
7.
Indeed. Is 7 on the, it's a linear equation. We move 42 and divide by 6.
Oh, okay.
Is 7, yes.
Yeah, can you go back up just a little bit? No, down, I'm sorry. Well, you got that 4x negative 20. Okay, I understand how you got that, but how did you get negative 32? I know you said you put the 1 over there, but what made that a negative 32?
There is a
Oh, the
negative.
minus sign. Okay, I thought it was the equal sign. Okay.
No, the equal sign is right here. The equal symbol is right here. We moved this term to the other side and
Okay.
make that equal to 0. So after you saw the second example, do you feel a little bit better about it? It's not such a big deal, but it's not a trivial equation.
It's not hard. I just do that part
I
at
just
the
do
top. I do the parentheses and I distribute. What you said you don't do, that's just how I do it. So when you be moving on.
Acceptable. As long as you know what you're doing, I'm fine. Very good. Any questions for me? Any questions?
Could you say that rule again? What's the fraction of 0 over 1?
Yes,
One more time.
yes, very good. So A divided by B is 0 only if A is 0. You can also write if B is 0, A over B is undefined. Very good. Any questions? Any questions?
Can we see one with 0? Because
Say
I
it
want
again.
to see how one look with 0. When the answer is going to be 0. Because I don't,
Well, I can make one up.
can't make it.
No, I mean, I can, but I need time. I can just in a second give you an equation that will eventually have x equals 0.
Okay.
Oh, you mean x equals 0 or no solution?
No solution.
No, see,
Oh, you mean no solutions?
Yeah.
Okay. Well, let's give it a shot. 49. Very good point. 49. 1 over x minus 4 plus 5 over x plus 2 equals 6 over x squared minus 2x minus 8.
49 and some minus.
Yes, I was just going to correct that. Thank you. I normally designate one student in the class to double check what I copy. Yes, sometimes I copy half of the problem from one. And then I've got, because I'm standing here, there's not enough light, and sometimes, yes, but I always check before I start. So I'm checking now. 1 over x minus 4 minus 5 over x plus 2 equals 6 over x squared minus 2x minus 8. Very good. Okay, rational equation. We have a long procedure. First step would be to, yes, again, if you prefer my method, minus 6 over And now I have to completely factor x squared minus 2x minus 8. And this was the next step anyway today, to review with you factoring before we move on to 1.5, which is quadratic equations. So how do we factor x squared minus 2x minus 8?
You gotta find the
Two numbers whose product is
8. Is it?
with a sign always, negative 8, and whose sum is, very good. Can we find two numbers whose product is negative 8 and whose sum is negative 2? Well done. Right. So in general, I'm not teaching you how to cheat, but in general,
The answers are yeah.
it should be something like this, because in this class you're not going to see way sophisticated types of rational equations that are way more difficult. Okay, so always try to look and double check, you know, anything can happen. So what will be the factor form then? Very good, awesome. So then you're going to give me two restrictions. The restrictions are extremely important. You will see later why. So you're going to give what restrictions again?
-4.
Why -4? -4 minus 4 is not 0.
Positive
Correct? You have to move
and
-4
2.
and -2. Is that clear?
Say it again.
X minus 4 equals 0. I move -4 to the other side and I get x equals 4. X minus 4 not equal 0. X not equal 4 when I move it to the other side.
Okay.
-4 minus 4 will not be 0.
Okay.
But 4 minus 4 will be.
Okay.
So these are the restrictions. Good. The least common denominator, please.
X
Adjustments for the tops.
times 2. I mean, yeah. X plus 2. X
Good.
plus 2, yeah. X minus 4.
Good.
1.
Or nothing. Good. So now,
2x plus 2.
good.
20. X minus 20. No, negative 20?
Wait, I can't see.
X,
That's minus,
X minus 20.
that's 5x.
Good.
oh, why
Hold
is
on,
it
wait,
5x?
wait.
Because 5 is
Five
greater.
Oh, okay. It's a number right there. The other one is 1, but that's 5.
You see that's 20.
So the symbol, I have,
Negative
It's
20.
X minus 4.
Oh, it's not- is it not two divided?
I mean,
It is, that's true.
very good. So now let's combine like terms at the top. What do we get when we combine like terms? We get a -4x, right? And then 22 minus 6 divided by x minus 4, x plus 2, 0 over 1. If you cross multiply, or you just say a fraction is 0 when the numerator is 0, what do I write? This times 1 is -4x plus 16 equals this times 0, which is?
0,
0.
So -4x equals -16, so x equals 4. However,
It can't be 4.
it cannot be 4 indeed.
So,
So what do I conclude about this equation?
no solution.
Indeed. The equation has no solutions. Any questions? Okay, now I would like us to go to the factoring supplements. This one. Because the next section is 1.5, solving quadratic equations. And the first step, yes? You were not here last time? Okay. If you want to come up. So we have to talk at the end of the class because I have more documents for you. And I'm looking for that specific one. You need 9 documents. Thank you. Okay, so the next section is 1.5, quadratic equations. And we have 4 methods of solving quadratic equations. Number 1, factoring. Number 2, taking square roots. Number 3, completing the square. And number 4, quadratic formula. And now the obvious question here is, 4 methods? Really? What happens to 1 or 2? Why 4?
That's how it becomes quadrant.
Are you Megan by any chance? Are you Megan? Okay. Good. So the reason why we have 4 is because they all have different situations in which they are applied. Which do you think is, or which are the ones that are always applicable for in any situation, always forever? Quadratic formula, very good. Factoring, not. It's the only one that is not always applicable because not all polynomials are factorable. So this is the only one that may work or not. All the other ones will always work. Because I can always complete the square and then take the square root, and I can always apply the quadratic formula. Later on, after we discuss all 4, I will tell you which one we apply when as the best option, okay? And which one is not applicable at all, and when. Okay, so now I would like to go back to factoring, and I would like to go through that document on factoring, so then we don't have to talk about it again, hopefully. But if we do need to, we will. So I divide factoring into 3 different groups with 3 different strategies. So here they are. Binomials. Second one, trinomials. And polynomials. They are all different. Some similarities exist, but they're all different strategies. So let's start by factoring binomials. How many terms does a binomial have?
2.
Indeed. Very good. So here's the strategy for, and I am going to ask you, or I'm going to go through these steps all the time. Step 1, what is it? And I have to say binomial. Step 2, is it in descending order? If it isn't, then I have to rearrange it in descending order. Step 3, is there a greatest common factor? If there is one, I will pull it out. Step 4, negative leading coefficient. If there is a negative leading coefficient, I will pull it out. Step 5, and the last one here, special products. Okay, one more time from the beginning. Number 1, what is it? Right, so I have 3 answers, not yet because we haven't reviewed those, but I will have potentially 3 answers. It could be a binomial, it could be a trinomial, or it could be a polynomial. That's why I have to start with that question. Question number 2, is the polynomial in descending order? If it isn't, I will rearrange it. Question number 3, is there a common factor? If there is, I will pull it out. Is the leading coefficient negative? If there is, I will pull out -1. These two can be performed in one step. And then a special product. When it comes to binomials, there are 4 different special products that we have to talk about. The first one we already did. A squared minus b squared. How do I factor this? Danny or
A squared,
never?
no,
A plus
A plus B plus A minus B.
Very good. Very good. So this is the first one. Number 2, a squared plus b squared. So the first one is called the difference of squares, correct? Diff of squares. What do you think this one is called?
Similar A squared.
Sum
Sum of squares.
of squares. But this one is not factorable. To be exact, is not factorable using integers. But we say not factorable. Your book or some books say prime. I really don't like that, but you can use it. It's fine by me. The other 2 special products are more sophisticated and more difficult. So before we move on to number 3 and number 4, let's do this. Let's say I'm asked to multiply. What is this? How many terms does it have, and what is the name? Very good, awesome. And I'll say this. And how many terms, and what is this?
Try to
Excellent. So I'm asked to multiply this particular binomial by this trinomial. How do I do it? Well, step by step. I multiply a by these 3, and then I multiply b by these 3, and then combine like terms. Hopefully, I have terms to combine. Okay, so let's do it. A multiplied by a squared to the 3rd minus a times ab is a squared b plus ab squared. So we distributed a to these 3 terms. So far so good? Now plus, I am distributing b to these 3 terms. A squared b, very good, minus,
AB squared,
very good, awesome, and then plus.
B
B to the third.
third.
I'm hoping that some terms go away. Do they?
Yeah.
Yes. Which terms go away?
AB squared.
AB squared indeed.
No, A squared.
Negative a squared b with positive a squared b. And what is the final answer?
A cubed minus
O plus B.
O plus B.
How do you think this is called? The sum of cubes. Very good. So we looked at the difference of squares. We looked at the sum of squares. This is the sum of squares.
What's the name of that one?
And now we're looking at the sum of cubes. So this is number 3, a cubed plus b cubed. And then the last one will be, the last special product will be a cubed minus b cubed. Any questions? Let me know. Any questions? So now, based on what you see here, if we ever encounter, and we will, the sum of cubes, how will you factor it? As a,
binomial times the trinomial.
exactly, a binomial times a trinomial. Same thing with the difference. Let's establish the sequence of signs first. So we got the sum of cubes when the binomial had the sum and the trinomial had minus in the middle. We never discussed this one because it's always positive. So if it's plus, what do I have in the middle? In the binomial. And what do I have in the middle of the trinomial?
Minus.
If it's minus, what do I have in the middle of the binomial? Good. And
Plus.
very good. So the binomial always follows suit, if you want, or follows what I'm trying to factor. And the trinomial will always be the opposite. Megan, can you put that away, please? Thanks. I didn't say you're not here last time, but there are no cell phones in my class. Thanks. Okay, so now let's figure out what we have. So what do I cube to get a cubed? I know it's silly. It's very clear. What do I cube to get a cubed? Of course. What do I cube to get b cubed? Excellent. Now here's how we remember the trinomial. I square the first term, I square the last term, and just the product is in the middle. So can anyone give us the binomial in the difference of cubes?
A minus B
A cube
squared,
square, yeah. I mean, B square,
AB
A B, A B.
minus B.
The last one we don't even discuss ever. The last term, it will always be positive. Very good.